In this video, we're going to be solving trigonometric equations. In this example, we have solved 2 times the sine of x minus 1 equals 0. So we want to try and isolate our sine of x by itself. Now what you might notice is the graph over here to our right. Now that graph happens to be the graph of 2 times the sine of x minus 1. But we're going to try and get our sine of x by itself. So we're going to start off by adding 1 to both sides. We're going to add 1 to each side, and that's going to leave us with 2 times the sine of x equals 1. Then we'll divide both sides by 2, and that's going to give us that the sine of x equals 1, let's try that again, 1/2. So now, if we take our equation sine of x, we want to know where our y values are 1/2. So if we take a look at our graph and we look at the line y equals 1/2, and we're getting that from right here. Because think of like an xy table. So this would be our input, and this is our output, right? Or our y value. So we want to know what values of x will allow us to get that 1/2. So if we take that 1/2 and we mark it right there, that dotted line right there, we see that we have a few different intersection points. Those intersection points are the x values that will work. So here we see that we have, let's use a different color. Let's use purple. So here we have a pi over 6, and it happens in 5 pi over 6. And that's within our 2 pi limit. Now you'll notice that it happens again here, and it happened at the pi over 6, but it was in the second period, so it's plus a pi over 2, or excuse me, a 2 pi. And then again at 5 pi over 6, but plus 2 pi. And if we were to work backwards, we would see that it occurs at the pi over 6 minus 2 pi and 5 pi over 6 minus 2 pi as well. And the reason for that is on our unit circle here, we've got our 0. Let's use green. So this is our 0, and this is pi, right? But this is also 2 pi, so all the way around. And so if we think about this, if we're going around the circle and we hit these points at pi over 6 and 5 pi over 6, well, we're allowed to go around the circle more than once. So as we finish that completion around the circle here and we start to go again, we're going to notice that we end up hitting it again on the same points. We're still hitting it also at the pi over 6 and 5 pi over 6, but now we're having to add on a 2 pi because we're in the next revolution of that circle. So when we write our final answer, what we're going to put is that x equals pi over 6 plus 2 pi times n, and that x also equals a 5 pi over 6 plus 2 pi n. And you'll always have these plus 2 pi n's there. Now sometimes this is rewritten just to make it a little bit easier for us for multiplying as pi over 6 plus 2n pi, and x equals 5 pi over 6 plus 2n pi. And the reason for that is that our answers are going to stay in pi form. So we're not going to actually multiply out the pi. And so what that does is it keeps the two n's, the things that we're going to multiply together. And so this is our final answer. Let's do another example. Here we have find all of the solutions of the sine of x plus radical 2 equals the negative sine of x in the interval 0 to 2 pi. Now notice that this time it's giving us an interval where it didn't give us an interval here. And so because it didn't give us an interval, we had to add on this 2n pi to that. But because we are inside of this interval of 0 to 2 pi, it's saying that it's only going to exist in one circle. Sorry, let me try that again. In one of our unit circles. And so we can only go from 0 to 2 pi. So going to 4 pi isn't an option. So because of this right here, it's okay to leave off our 2n pi on the solutions. So let's go ahead and let's work this problem out. So we're going to begin by adding the sine of x to both sides. So we're going to get rid of this sine of x. We're going to move it over here with this other one so that we get a 0. So now we have a sine x plus a sine x is a 2 sine x, because we have 2 of them now, plus the square root of 2 equals 0. Then from here, we're going to subtract our square root of 2 and move it over. So now we have 2 times the sine of x equals a negative radical 2. Then we're going to divide both sides by 2, and that's going to give us that the sine of x equals a negative radical 2 over 2. So we want to know where on the unit circle do we get a negative radical 2 over 2. So if we pull up our unit circle, we see that we have a negative radical 2 over 2 with the sine of x. So remember, we're looking for where is the y value, right? Where is the y value? And the reason we're looking for the y value is because it's a sine of x. So we're looking for the y value. So where is the y value? A negative radical 2 over 2. And we see that that happens here and that that happens here. So it's happening at 5 pi over 4 and it's 7 pi over 4. So we're able to say that our answer is 5 pi over 4 and when x equals 7 pi over 4. And again, remember that because we are living in this interval, just within one unit circle, one period, that we don't need the plus 2 and pi. And so this is our final solution. Let's go ahead and look at one more example, one that's a little bit different. So here we have solve 3 times the tangent squared of x minus 1. Now this one's a little bit different because our period for a tangent is only 1 pi, but our period for a sine and a cosine and a secant and a cosecant is 2 pi. And so the period for tangent and cotangent is pi, which means that instead of adding 2n pi to each answer, you only need to add just the pi, or rather n pi. So what does that look like? So we have our equation, 3 times the tangent squared of x minus 1, and we're going to begin by adding 1 to each side, so that we have 3 times the tangent squared of x equals 1. Then we're going to divide each side by 3, which gives us the tangent squared of x equals a 1 over 3. But then we need to find the square root to cancel that out. So that's going to give us the tangent of x equals plus or minus the square root of 1 over the square root of 3, which becomes plus or minus 1 over the square root of 3. And we can't have a radical in the denominator. So we'll rationalize our denominator, which will give us a plus or minus radical 3 over 3. So what we're looking for here is the tangent of x equals plus or minus radical 3 over 3. So let's turn to our unit circles. Now your unit circle is something that you definitely want to try and have memorized because this is going to make this a lot easier, So we want to find for our tangent. Remember that tangent is the y divided by the x value, right? So we want to know where, when we divide the x by the y, do we get radical 3 over 3? And so if I know I want a radical 3 on the top like that, I know that I'm going to end up having a situation where I'm going to have to rationalize my denominator. So what I might try, let's just try this one here, this pi over 6 first. And so here we've got the y, which is 1/2, divided by our x, which is radical 3 over 2. And when I keep, change, flip this because it's a fraction, so I keep, change, flip, that's going to allow me to cancel out those 2's. And I'm going to have a 1 over radical 3, which is kind of looks like that one. So I'm pretty sure we're in the right direction here. So we're going to multiply by the radical 3 to rationalize it and get our radical 3 over 3, which is what we want. And so we need a positive 1 and a negative 1 of those. And so we're going to do, so pi over 6 works, and that gave us a positive. So we want to look and see where else do we see the radical 3 over 2 comma 1/2. And we see that happening in a few different places. But remember, let's see, we see it here and here and here. But recall that we only have to go to a period of pi, which means we're only looking in quadrant 1 and quadrant 2. So we're only looking in this upper quadrant right here. So that means that we're going to ignore these values. So that tells us that we're going to be using pi over 6 and 5 pi over 6 as our answers. So we'll say that x equals pi over 6 plus n pi, and that x equals 5 pi over 6 plus n pi. Because remember, we said that instead of adding 2n pi, we only needed to add n pi. And that is going to be the solution to our equation here.